The weightage of chemistry practicals is 30 marks. Out of 100, 70 is your theory and 30 is your practicals. Your practicals are divided into 4 categories or 4 experiments. Your experiment number 1 is your volumetric analysis. Your volumetric analysis is a quantitative analysis where you do titration to calculate the strength and molarity of an unknown solution. This has weightage of 10 marks. Your experiment number 2 is your salt analysis, which is a qualitative analysis where you identify the anion and cation present in the given salt, which has a weightage of 8 marks. Your experiment number 3 is your content-based experiment. In this you have experiments like chromatography, functional groups, colloidal and so on, which has a weightage of 6 marks. Your experiment 4, which is nothing but your Viva project and Viva based on your project. This put together is your 6 marks. So total is your 30 marks. Today we'll be discussing about salt analysis, which is your experiment number 2. In your salt analysis, you will analyze an unknown salt to identify the cation and the anion which is present in it. So the aim of your experiment would be to identify the anion and the cation in the given unknown salt and to record your observations systematically. Okay. Now this experiment is divided into 2 parts. Now whenever you do salt analysis, there are few things you have to keep in mind. Number 1, we do the anion analysis first. But the moment a salt is given to you, you will go for something which we call as your preliminary observation. In your preliminary observation, you will look at the color. Okay, some of the salts are color and the color of the salt is due to the presence of your cation. Your copper salts are blue in color. Your ferric salts are reddish brown in color. Your cobalt salts are dark pink or dark red in color. Your manganese salt are very light pink in color. And your nickel salts are bluish greenish in color. Ammonium salts, zinc salts, aluminium salts, barium, strontium, calcium, magnesium, all these are white in color. So moment you mention the color, if it's a colored salt, then you will be deducing it. For example, if I say the color is blue, then I can deduce that may be copper. That means copper may be present. Right? Second thing is your smell. Usually smell is observed only in 2 types of salts. Ammonium. Most of the ammonium salt tend to give ammonia. Therefore, you will have smell of ammonia. Or your acetate salts, okay, they will give you smell of vinegar. Otherwise, you may have sometimes a pungent smell, unpleasant smell, which you can mention it out here. Then the third thing that you observe is your crystalline or amorphous. If it is an amorphous salt, what do we conclude is that maybe your carbonate is present. And if it's a crystalline salt, then you may have a nitrate, a sulfate or a chloride. Okay, now this is only certain hints to tell you what it can be. You can't take something which is crystalline, has to be nitrate or has to be sulfate. This is just a guideline. And the last thing that you see is your solubility in water. Now most of the salts which are provided to you are soluble in water. Water insoluble salts are no longer in your syllabus, so the salts which we provide you should be soluble in water to a large extent. Okay, so once you have noted down your preliminary observation, then we move on to the anion analysis. Now this is divided into your three groups. Dilute H2SO4 group, then is your concentrated H2SO4 group, and then is your special group. Salts which are easily decomposed by dilute H2SO4 are kept under dilute H2SO4 group. Now dilute H2SO4 is your group reagent for this particular anions, and the anions which are there in this group is your carbonate, sulfide and your nitrite. Now when we add, we take a pinch of salt. Now the way you proceed is you take a pinch of salt in a test tube and then you add dilute H2SO4. Now if you observe a colorless, odorless gas coming out of the test tube which turns lime water milky, then you can assume that the gas which is given out is your carbon dioxide, which will basically tell you that the anion present is your carbonate. In case you have a colorless gas with the smell of rotten eggs, then it could be due to H2S. Therefore, the anion present could be your sulfide. If you have a colorless gas with a pungent smell, then it could be your SO2. And if SO2 is being evolved, you can deduce that sulfide may be present. In the case of nitrite, you will have a brown pungent smelling gas, which is your NO2. So the gas which is given out will indicate the kind of anion which is present. But just getting the gas is not enough. You should know how will you verify the gas given out is so and so. For carbon dioxide, we perform something which we call as the lime water test. H2S, how do we with a lead acetate paper, if I use a lead acetate paper, what will happen? Your lead acetate combines with, or it reacts with H2S to give you something which is PBS, which is blackish brown in color. So the paper converts, or the paper, you will have a blackish deposited on a lead acetate paper, which will verify the gas given out is H2S, which will further give you an idea that the anion is S-2. Similarly for sulfur dioxide, now you have done P block, so you know that in sulfur dioxide is reducing in behavior. So if I treat it with acidified KMnO4, so KMnO4 is decolorized. If KMnO4 is decolorized, the gas given out should be your SO2. For NO2, we pass the gas through ferrous sulfate solution, we get a blackish deposit. So we have to do these tests also to verify the gas which is given out should be NO2, SO2, H2S or CO2. Once you have analyzed, the dilute H2SO4 gives you the hint about the group in which the anion could be present. Now based on your observation which you have it over here, for example, if you have a colorless, odorless gas which is turning lime water milky, then you can say it is carbonate. Then you will proceed with the confirmatory test of carbonate. Now if it is a brown colored gas which is given out on addition of dilute H2SO4, then you can assume that this is NO2 minus, and then you will proceed with the confirmatory test of NO2. Similarly for other one, once you have analyzed anything is present, if there is an effervescence, there is a gas liberated in this particular group, then you will do the respective confirmatories. It may happen that your anion is not present in this particular group, then you will have no reaction or no observation. Then we will move on to the next group, which is your concentrated H2SO4 group. In your concentrated H2SO4 group, the anions which are present is all your halides, chloride, bromide, iodide, nitrate and your acetate. Now again what you will do is, in a fresh test tube, you will take a pinch of salt and to that you will now add concentrated sulfuric acid. Now when you add concentrated sulfuric acid, again you will have an observation in case any of these anion is present in your salt. In the case of Cl-, you will have a pungent smelling gas which is your HCl. Now how will I confirm that the gas given out is your HCl? Treated with NH4OH. Now how will I do it? I will take a rod dipped in ammonium hydroxide, bring it near the mouth of the test tube. What I get is dense white fumes. These dense white fumes confirm the presence of HCl, which will further confirm the presence of Cl-. In the case of Br-, you will have reddish brown vapors. Can you tell me which gas will be involved? This is your Viva question. The gas given out here is Br2. In this case, I am evolving HCl. In this case, I am evolving Br2. Now, why is it so? The reason is the HBr, which is evolved initially when bromide salts are treated with H2SO4, they are further oxidized by sulfuric acid to give you Br2. Because the bond strength of HCl is higher, so this is not possible with HCl, but it is possible with Br- and I-. In the case of iodide, you will have violet vapors being given out. For NO3, the gas which is given out will be again reddish brown in color. Okay, and in the case of acetate, you will have smell of vanilla. A gas is evolved, this is nothing but your acetic acid vapors, which is giving you the smell of vinegar. So any such observation will indicate the respective anion. In case of nitrate, this is one of the most difficult anion to be detected. The reason is when you add concentrated sulfuric acid initially, nitric acid vapors are given out, which are seen as white fumes, which is similar to your observation when HCl is evolved. So wrongly you people conclude that this is a chloride salt where it has to be a nitrate salt. Now the nitrate salt, the reddish brown gas which is evolved, is always evolved after heating. The nitric acid which is initially given out, on heating decomposed to give you NO2, and we need to verify that this has to be nitrate. So what we do is we add copper chips or carbon pellets. Carbon pellets is nothing but paper balls that you can make from your filter paper. You add that, the reddish brown fumes will be intensifying. If they are intensifying, it has to be nitrate, or if they don't intensify on adding copper chips or carbon pellets, then it has to be a Br-. Okay, so this is regarding your second group, which is your concentrated sulfuric acid group. Salts which cannot be decomposed easily by your dilute H2SO4 or concentrated H2SO4 are present in your special group. So in your special group, you have two anions, which is your sulfate and your phosphate. There are no special or preliminary tests for these two. We have individual tests. The kind of test that we are performing here, which only indicates the presence of a certain anion of a particular group, that is basically known as a preliminary test. So all these are your preliminary tests that we have discussed up till now. Once you are able to analyze the anion in the preliminary stage, then you will have to perform the respective confirmatory test for each one of them to confirm the salt.
Yeah, you saw that ma'am was describing about the anion analysis divided into three portions. Dilute sulfuric acid, that is some anions can be tested by using dilute sulfuric acid, some by concentrated sulfuric acid, and we have the special group as well. So now I will just perform one or two for a carbonate, for a nitrate for example, and how will you analyze. So let me take a carbonate salt. Okay, let me take a carbonate salt and in the dry test tube just a little bit of carbonate salt, and then you just add what is the dilute sulfuric acid group. This belongs to the dilute sulfuric acid group. So you use the dilute sulfuric acid. Okay, so this is dilute sulfuric acid, where you will be adding a little bit to this. Can you see the brisk effervescence coming out? So it is a carbonate salt. The gas evolved is carbon dioxide. As you know, the carbonate salt is giving out carbon dioxide. This carbon dioxide salt, when you add lime water to it, should turn milky white, right? It should turn milky white. Just add lime water. I am adding lime water. It should turn milky white because of the formation of that calcium carbonate. Okay, so again you should see that. So the brisk effervescence that was evolved is carbon dioxide. Let me take, that was for carbonate salt. Let me now go with an example for the concentrated sulfuric acid group, where let me take a nitrate salt. Okay, so let me take a test tube. We take a nitrate salt. I am just taking cobalt nitrate is the example that I have taken here. a nitrate, and to this you see when I add dilute sulfuric acid, I see nothing has happened. There is no change, there is no gas evolution, isn't it? So we didn't see any brisk effervescence or anything. So nothing has happened. So my radical, your salt will contain only one radical, which is either in one of these groups. So in dilute sulfuric acid, when I added, I didn't find any change. So it does not belong to this group. So I move on to the next group. That is, I go ahead with concentrated sulfuric acid. I take the salt. I just add a little of the salt in the test tube, and then I add a drop of concentrated sulfuric acid. Use your test tube holder always when you are using concentrated acids. Never forget to use that. Okay, so always when you are using concentrated acids, please do use the test tube holder. Just add a drop of concentrated sulfuric acid. Now you see some small fumes are coming out, but it's as ma'am mentioned, it is not a chloride or anything. So just go for heating of this. Okay, just heat it and you observe, you just see what's being observed there. When you heat, please keep the test tube in a slanting position away from your face as well as your friend's face, and you can see that some gas coming out. Can you see the gas coming out? Can you see some reddish gas coming out, right? You can see that reddish gas coming out, and now when the reddish brown gas is being evolved, I get confused whether it is a bromide or a nitrate. So in that case, how do I go about it? If it is a nitrate, I can either confirm by adding some copper turnings. Okay, I will add some more copper turnings to it, and I'm just adding some copper turnings. I can see that the reddish brown fumes are intensifying. Are you seeing that? The reddish brown fumes are intensifying, and then you can see that the reddish brown fumes are coming out, right? If it was a bromide, it would not have intensified like this. It got intensified, and this gas, if you want to still further confirm, this gas can be passed through the ferrous sulfate solution. On heating, this is the nitrogen dioxide gas, NO2, coming out, and when it is passed through the freshly prepared ferrous sulfate solution, okay, just you see that the gas is passed. And you close the thing and just shake. You can see that it becomes black in color. Which one? Ferrous sulfate will become black in color because of the passage of this NO2. Okay. So you will just use this to confirm whether, so when you added this salt solution, added a drop of concentrated sulfuric acid, you saw some fumes. We wanted to confirm, we heated it, we saw some reddish brown gas, and to confirm whether it is a bromide or a nitrate, I added copper turnings, and the brown fumes intensified. These brown fumes, when I intensified, I just added a little of this, passed this gas over the ferrous sulfate solution, which turned black. That is not necessary, I just did it for your confirmation.
Now confirmatory for nitrate is brown ring test. Ma'am has already shown you the preliminary test with cobalt nitrate. I have taken another salt, ammonium nitrate. You can see it's a crystalline salt and it's deliquescent also. So first what we do is we'll make a salt solution. To make a salt solution, you'll take the salt, add water and shake it so that the salt dissolves. Now to this salt, what we will add is a freshly prepared ferrous sulfate solution. Ensure that the complete salt has dissolved, otherwise we'll have to filter it. So more or less it is soluble. I am adding freshly prepared ferrous sulfate solution to it. After adding your ferrous sulfate solution, you will be adding concentrated sulfuric acid by the side of the test tube. The ring is formed at the junction of the aqueous layer and the sulfuric acid layer. So what we do is we tilt the test tube, because if the solutions mix then we don't get the ring. The ring is formed at the junction, so tilt the test tube, add sulfuric acid by the side of the test tube, and you will observe a brown ring at the junction. So it is coming. You will get a ring like this. A brown ring like this is formed, which is a confirmatory test of nitrate. Can you see the now brown ring being formed at the junction of the two solutions? So this is how you perform your brown ring test. It's very important for you to do this test properly. Sulfuric acid should be added by the sides of the test tube, and the ring is formed at the junction of the two. And it should look like a ring, it should not look like a band. After analyzing the anions, you will analyze a cation. Now, cation analysis is divided into 7 groups. We start with the 0th group, which has ammonium as the cation. Ammonium is done in the beginning because we use many ammonium reagents during the analysis in the 3rd group, 4th group and 5th group. To avoid any kind of confusion, ammonium is kept in your 0 group. Ammonium doesn't have a group reagent. You simply add sodium hydroxide to the salt. Ammonia is liberated, and you can check whether ammonia is being formed from the smell. And second thing is, you can bring a rod dipped in HCl near the mouth of the test tube, where dense white fumes of ammonium chloride are given out, which is a confirmatory test for ammonia gas. After you have got this smell of ammonia and dense white fumes of ammonium chloride, you can perform the confirmatory test for ammonium ion, which is with Nessler's reagent. Suppose there is no observation on adding NaOH, then we move on to the first group. In first group, you have silver ions, mercurous ion and lead ions. Mercury and silver are a little costly, so we only do lead salts in the lab. Okay, the group reagent. Now, what do we mean by group reagent is the reagent which gives you an idea about the group. That means you will have some observation if that particular cation is of that group. That means when I add dilute HCl to any of these cation salt solution, I will have an observation. In the case of lead, the observation is on adding dilute HCl, you will get a white PPT. Now this white PPT is of lead chloride. Now once you obtain that white PPT, you can carry out the confirmatory test for lead. Moving on to the second group. In the second group, you have copper, arsenic and cadmium. Arsenic is a little poisonous and cadmium is costly, so again we only concentrate on the copper ions. As already discussed, copper ions are blue in color. So the color itself will give you an idea whether you have the copper salt or not. But from the color, still we need to do confirmatory test, we need to do preliminary test to identify the cation. The group reagent for this is H2S in the presence of HCl. It's very important to understand, when I say H2S in the presence of HCl, that means when I add H2S, HCl should already be there. So how you will go about the test is, you will take the salt solution, you will add some amount of HCl, 2-3 drops of HCl, and then you will put your H2S. The observation would be a black PPT of copper sulfide will be formed. If you get a white PPT, black PPT, then you can do the confirmatory test for your copper, which will verify the presence of copper ions in the salt. Again, if you don't obtain any kind of an observation in this, we move on to the third group, where you have ferrous-ferric, but usually we do ferric ions only, and your aluminium. The group reagent out here is NH4OH in the presence of NHCl. When I say in the presence of NHCl, that reagent is added first. So what you will do is, you will take your salt solution, you will add ammonium chloride solid to it, ensure that the ammonium chloride gets dissolved, and after that, how do you test that enough ammonium chloride is present? The test tube should smell of ammonia. So when you add ammonium chloride, dissolve ammonium chloride, if the test tube is smelling of ammonia, after that you will add ammonium hydroxide. In the case of ferric, you will have a reddish brown PPT. In the case of aluminium, you'll have a white gelatinous PPT. If you have these two observations, then you can carry out their confirmatories to confirm the presence of these cations. In case it is not, or you have no observation, no precipitate formation, you will move on to the fourth group. Now in the fourth group, the group reagent is H2S in the presence of NH4Cl and NH4OH. Again, what you will do is you will take the salt solution, you will add ammonium chloride to it till it smells of ammonia, and then you will add ammonium hydroxide, and after that you will pass your H2S gas. For zinc you will get a white PPT. For nickel you will get a black PPT. For cobalt also you will have a black PPT. And for manganese you will have a buff color. Now buff colored basically means the color of your skin or very light pink. If you have any one of these observations, then you can proceed for the respective confirmatories. Now in the case of nickel and cobalt, as they both have black precipitate, so we have to do, if you check your confirmatories, you start in the same manner, and towards the end when you add different reagents, you will be able to confirm whether it is nickel and cobalt. But initially also we know that nickel and cobalt salts are colored. So nickel salts are bluish greenish in color and cobalt salts are reddish in color, which will indicate that what kind of cation should be present, and you can carry out your confirmatories in the same manner. Coming to the fifth group. Now the group reagent for your fifth group is ammonium carbonate in the presence of ammonium chloride and ammonium hydroxide. Procedure remains the same. You take a salt solution, you will add ammonium chloride and then ammonium hydroxide, and then you will add ammonium carbonate. They are all white in color and they are precipitate as their carbonates. So the reagent which is written over here in the presence, now you know that your this scheme is based on your solubility product and common ion effect. So you need to understand the common ion effect and the Le Chatelier's principle and the kind of precipitates which are being formed. Okay, so over here carbonates are there, now you get a white precipitate, carry out the confirmatory. Now you should keep one thing in mind, that confirmatory tests are always performed in the order of first confirm whether barium is there or not, then strontium and then calcium. Remember BSC. If barium is not there, then only you will move for strontium. If strontium is not there, then only you move for calcium. If this is negative, then move for this. When these two are negative, then only move for your calcium. Okay, so once you have indication, now one more way by which you can have an indication of the kind of cation which is there, whether it's a barium or a strontium or a calcium, is to do a flame test when you do the preliminary observation. In the flame test, what you will do is you will make a paste of salt with concentrated HCl, take it on a platinum loop, and then that paste you put it into the flame. If color is imparted to the flame, and the kind of color which is imparted will indicate the presence of barium, strontium or calcium. Color for barium is green, that's apple green color. Strontium is your crimson red, which is rustish in color, and calcium is your brick red or blood red. So if you have these color imparted to the flame, they will indicate the presence of your barium, strontium or calcium. Once you have done the flame test, it is easy to perform the confirmatory. If you don't get any kind of a precipitate in the fifth group, then you will move on to the sixth group, where the reagent which is used is sodium dihydrogen phosphate. So you will take your salt solution, you will add this, scratch the test tube a little because you need to do seeding for precipitation of this. Again you will get a white PPT. The precipitation of white precipitate, that is basically a magnesium phosphate, will indicate the presence of your magnesium ion. So you do this analysis and you will be able to identify your cation. For the cation analysis, you just follow the scheme stepwise. You will not face any difficulty in doing any of the tests. The only tricky test in cations is your flame test, how to perform it and to observe the flame. Now I have 3 samples. This is your strontium, calcium and barium. To each one of them you will add concentrated HCl, okay, so that a paste is being formed. And then you will take a little amount of that paste on a platinum wire. You'll make a loop towards the end of the wire and then put it into the flame. Can you see the color now? This is your crimson red. So this is your strontium sample. So the color which is imparted to the flame you will be able to identify the cation with it. Okay, now you see that whole of strontium has been on. Ideally I should wash it and treat it with acid, but just to show you people again, I'll dip this in your calcium salt, which is now can you see some streaks of colors being coming out? So that is for your calcium. So a color is imparted to the flame. Now you can see the beautiful color which has been imparted to the flame, by which you can detect your calcium, which is your brick red. This is your brick red color. Fine. So brick red coloration to the flame will indicate calcium. Okay. Now let's see what happens with barium. So you will take your barium, add concentrated HCl, make a paste, and then you should get a apple green color. So you can see some streaks of green color coming. The reddish change is because we had used earlier salts, but you will get some streaks of green color in between you're getting by a green apple. So that indicates your barium. So thank you. After analyzing the salt, it is very important that you should record it properly, because in your boards you have marks for each and everything. Like if you haven't written the aim properly in your answer sheet, you lose marks. If you haven't followed the format, you lose marks. If you have not written in ionic form, you lose marks. So it's very important that you should know how to write the experiment. The first thing that you will write is the aim of the experiment, which is to analyze systematically the given salt and identify the cation and anion present in it. So aim has to be there. After the aim, you will write down your preliminary observation, color, smell, state and solubility. This we've already discussed. For example, if you are given copper salt, so you will write down the color as blue, smell, copper sulfate doesn't have any smell, state is crystalline, and solubility, it is a water soluble salt. Some of the salts are partially soluble, so you can mention it over there, partially soluble. If the salt is white, you mention white. So all these things you will have to write. Okay. Once you've written your preliminary observation, you will always write the analysis of anion first. This is really important. Anions are written first, followed by your cation. Now in your analysis of anion, you will make the table having 4 columns: serial number, experiment, observation and inference. Experiment will be what you are doing, what you are adding and in which way. And you will follow this scheme. For example, dilute sulfuric acid group first you do, then followed by concentrated sulfuric acid group and followed by special group. Now suppose if you have a carbonate salt, what you will do is you will add dilute H2SO4, you will get the brisk effervescence, you will mention it over here, and then you will mention it over here, a colorless, odorless gas is evolved. Now again what I am emphasizing is please write complete sentences. Over here you will write down in the experiment part, to a pinch of salt taken in a test tube, add few drops of dilute H2SO4. In the observation part now you will write it down, a colorless, odorless gas is evolved with brisk effervescence which turns lime water milky. Inference would be, now over here it's very important, you will write both the ionic form as well as your name of the radical. Carbonate CO3-2 may be present. Now whenever you have your group test, then you will write down may be present. Now once you have got carbonate, there is no need to write concentrated sulfuric acid and the special group. You can simply, when you've written carbonate may be present, you can mention the confirmatories after that. The confirmatories you already know, magnesium sulfate test. So after that you will write down the confirmatory test, you will write down both the tests for carbonate, the observation, and in the same way now when you're doing the confirmatory, your may be present will change to is confirmed. So when you're doing the confirmatory test, instead of carbonate may be present, you will say carbonate is confirmed. Okay, now suppose I'm talking about concentrated sulfuric acid group. Carbonate is not there, let's say assume chloride is there. Then what you will do is, Negative tests are equally important. That means you will always start writing with the dilute H2SO4 group. You will say to a pinch of salt, dilute sulfuric acid is added. Then you will say no observation, carbonate, sulfide, nitrite, absent. Then you will say over here to a pinch of salt, concentrated sulfuric acid is added. For the chloride, the observation is a colorless gas with pungent smell is evolved, which gives dense white fumes with a rod dipped in ammonium hydroxide. So everything will come in the observation, and over here instead of carbonate the way I have written, you will have chloride may be present. Then when you say chloride may be present, then after that no need to write down the special group, just continue with the conformity test of chloride. That means your silver nitrate test, your chromalyl chloride test. Suppose there is no observation with concentrated sulfuric acid also. In that case, you will again say to a pinch of salt, add concentrated H2SO4, no observation, this ion may be absent. That means chloride, bromide, iodide, nitrate, acetate, absent. Then move on to the special group and you write down the test for the special group. Okay. Now once you have analyzed the anion, how will you write down the cation? Analysis of cation, again you will go group wise. So first thing that you're going to write is make the table as for the anion, 4 columns, serial number, experiment, observation and inference. Then you will write down for the zero group. Okay, the zero group is what? To a pinch of salt, you will say to a pinch of salt you add NaOH. Observation, a colorless gas with smell of ammonia is given out, which gives dense white fumes with a rod dipped in HCl, dilute HCl. Over here again, the same way you will write down ammonium may be present. You will write down the name also. Just the radical is not enough. You will mention ammonium may be present. Fine. Then when you say may be present, carry out the confirmatory and there is no need to continue. Now suppose if you don't have your ammonium present, then you will say pinch of salt, add NaOH, no observation, ammonium absent. Move on to the first group now. Then what will you say? Salt solution, to the salt solution you are adding few drops of dilute HCl. Observation, if it is there, you will mention white PPT is observed or formed, and your inference would be lead may be present, and then you continue with the confirmatory test of lead. Now suppose your first group is also absent, then over here in the case of observation you will again say no reaction, no observation, lead is absent. Continue till the group that you have. First, second, third, fourth, fifth, sixth group. Suppose it is magnesium, you will write down the negative test of all the previous group. That means for zero group, first, second, third, fourth and fifth group. All negative tests have to be written. There are marks for it. If you don't write negative test, your marks will be deducted. Till whatever point you get may be present, after that you have deduced which kind of radical could be there. For example, if it is cobalt, cobalt is in fourth group. So after that you get a black PPT, then you continue with the confirmatory test of cobalt. If it is barium, then write till the fifth group and then write down the confirmatory test of barium and so on. Once you have analyzed the anion and written it down, analyzed the cation, written it down in this tabular manner, the result is very important. 3 things have to be written. The anion present in the given salt is so and so, the cation present is so and so. You will write both the ionic as well as your name. For example, if you are writing chloride, so you will say chloride Cl minus. If the cation is, let's say, assume barium, then you will say barium and Da plus 2. Similarly, the salt is now, you will write down the name of the salt like barium chloride and the formula. So it's very important the way you write. Write neatly, avoid cutting and erasing. Be sure of your ionic form of radicals so that you know that you are putting the correct charges, and please write in sentences. Just don't write white PPT. White PPT is formed. That's the correct way of writing things. So white PPT is formed. A colorless, odorless gas is evolved. So sentence formation has to be there. And in the experiment, you have a habit of writing like salt plus plus plus. Don't write it like that. Make it in a form of a sentence. To a pinch of salt, add so and so, or to salt solution, add so and so. All the best.